The last example for this series includes a function with a radical sign. Although the process remains the same, the result works with the nature of the function. You are watching differential calculus. Let's have a peek of higher order derivatives. The first derivative, which everyone is already familiar with, is also written as y prime. But this is interpreted as dy over dx. In physics, aside from having the first derivative as a slope, it is also termed as the rate of tangency, velocity, or force. A derivative higher is called the second derivative, which can be called y double prime. So from dy over dx, take further derivative, which then can be written as the second derivative of y with respect to x. This type is also termed as the rate of curvature, acceleration, or Young in physics. Further down the line, a higher order derivative is the third, which can be termed as y triple prime. And taking it from the second derivative, we take its derivative again, resulting to the third derivative of y with respect to x. This is also called jerk or tug. There is also the fourth derivative, and this time we can term it as y quadruple prime, but it is still written as the fourth derivative of y with respect to x. This order is also termed as Jounce. Instead of 4 primes, this is denoted by y raised to 4, and the force enclosed in parentheses, which makes it different from the exponent 4. Let's look for the y triple prime of the function y as equal to negative x squared plus 2 times the fifth root of x squared. Before working on any differentiation steps, we take the radical sign out and convert the term into fractional exponent. The fifth root of x squared is then taken as x raised to 2/5. Now we can start. Let's start with the initial derivative, and that is by distributing d over dx to all terms of the function. dy over dx then becomes the derivative of negative x squared. The other term becomes the derivative of 2x raised to 2/5. Next is to employ the constant multiple rule, and that is by placing the constants before the derivatives. dy over dx then starts with negative 1, with the derivative of x squared. Add to this the constant 2 times the derivative of x raised to 2/5. Then we differentiate. dy over dx then becomes negative 1 with the derivative of x squared, which is 2x, and attach dx upon dx. The second term has the constant 2 times the derivative of x raised to 2/5, and that is 2/5 of x raised to negative 3/5. Then place dx over dx at the end. Simplify the whole thing at this point by cancelling out dx upon dx into 1. The first derivative is then taken as negative 2x plus 4/5 of x raised to negative 3/5. One step completed, so we start with the second derivative by differentiating the derivative we just solved. Next is to distribute d over dx among the terms of the binomial. The second derivative then has d over dx of negative 2x, and also the derivative of 4/5 with x raised to negative 3/5. Again, the next step is to place constants out of the d's. So the output then starts with negative 2 with the derivative of x, then also 4/5 with the derivative of x raised to negative 3/5. From the first term, dx over dx can then be simplified into 1. Having simplified the first term, we continue working on the second. The second derivative then is negative 2 plus 4/5 of the derivative of x raised to negative 3/5. That is negative 3/5 times x raised to negative 8/5. Then attach dx upon dx, which is then cancelled as 1. So the second derivative becomes negative 2 minus 12 upon 25 of x raised to negative 8/5. Without any d's found, we already have the second derivative. So off we solve for the third derivative, and that is by differentiating the second derivative. We distribute d over dx among the two terms. Y triple prime then has the derivative of 2 minus d over dx of 12/25 of x raised to negative 8/5. The first term is just pure constant, where its derivative is taken as 0. Next is to place the constants before the d's. So the third derivative of y with respect to x is equal to the constant negative 12/25 with the derivative of x raised to negative 8/5. We have nothing left to do but to differentiate the latter part of the term. So y triple prime is then the constant 12 over 25 with the derivative of x raised to negative 8/5 as negative 8/5 times x raised to negative 13/5. Then attach dx upon dx, which eventually becomes 1. So the third derivative of y with respect to x is simplified as 96 over 125 of x raised to negative 13/5. To make the exponent positive, take the reciprocal making the derivative 96 upon 125x raised to 13/5. And since the premise uses a radical sign, convert the notation into 1, making the derivative 96 all over 125 times the fifth root of x raised to 13.